I just did was that I timed the bowl. How long did it take to get to the bottom of the ramp from the top? It's your boy, Logan, representing new, no excuses win. And we about to get into some physics today. Woo! So get pumped up, all right? I'm making a video for a valuable reason. And the reason I'm making a video is to break down the process of how I'm gonna calculate how fast an object slides down a ramp utilizing physics. The physics that I will be using is Newton's third law. My boy Isaac Newton's third law says when two bodies interact, they apply forces to one another that are equal in magnitude but opposite in direction. All right, let me go ahead and clarify this and make it easier so we're not getting too much in depth and too much confused. Because if you like me, I get confused. So we're gonna take this, we're gonna take baby steps, and we're gonna take it one step at a time. All right, so let's keep this thing rolling. The materials I will be using are a dog bowl, representing the object that is sliding down the ramp. And the ramp, this board, is going to be representing the magnitude. And this projector is going to be sine theta of the magnitude. And I'll show you later, but I use sine theta of 30 degrees. And the reason we're going to be using sine theta, you're like, well, why aren't we using cosine? It's because it's respective to the x-axis. And we'll get to that later, but for right now, let's take it one step at a time. So, usually in this situation, the idea of drawing a free body diagram of forces occurring in the x-axis and the y-axis would be needed. But, in this situation, the unknown is the final velocity. Because we know that the initial velocity is at 0 because this baby right here starts at rest. And then when it comes down, with this right here where it ends is what we're going to be utilizing to calculate the final velocity. All right, so now we know that the initial velocity is 0 and the unknown is the final velocity. We're going to be using sine theta of the magnitude. We're going to be using gravity, acceleration, all of our knowns to figure out the unknown of the final velocity. All right, so let's keep this baby going. In this situation, like I said, the unknown is the final velocity of kinematics, but we have to identify which axis the force of velocity is acted upon. As we see, the action of force being applied takes place on the magnitude. Like I said, this baby right here, this long ass board. Oh, I didn't mean to cuss. Sorry. This long board is going to be the magnitude. Even though the magnitude, you see the magnitudes at an angle, and usually whenever you like an axis graph, you just think of this, X, Y. But I'm going to tell you why this magnitude is identified in the x-axis. So it's actually going to be respective to the positive x-axis, respectively. I'll show and identify this by rotating a picture of a free body diagram I constructed. All right, I even drew it out for you. All right, so let's look at this, all right? All right, so you're seeing it like this, right? But we got to look at what the object, where is it respective to the x and y axis? So this is the magnitude. If you look like this, but if you slant it, the magnitude is the x-axis, going down is the y-axis. All right, cool. So let's get started on it. Oh yeah. We know the mass of the bowl. I'll come show you the mass of the bowl. But anyway, I'm just going to tell you what it is right now. It was, I wrote it down. I'm probably going to go over 5 minutes, but you know, whatever. So the mass of the bowl was 164 grams. But our units of measurement in this formula is going to have to be in kilograms. So the way we do this is that we calculate grams to kilograms by multiplying 164 times 0.001, get the total amount of kilograms, and that's going to be 0.164 kilograms. Okay, so the formula is final velocity equals initial velocity plus acceleration times sine theta multiplied by the time it took to get from the initial spot to the final spot of the magnitude. As we remember that the time was 1.9 seconds. Remember when I started the video, I recorded 1.9 seconds. Okay, so I'm going to reillustrate. Final velocity equals initial velocity plus acceleration, which acceleration is going to be known to gravity, and gravity equals 9.81 meters per second squared. Okay, so let's go ahead and write it out. Final velocity equals initial velocity, but initial velocity started at rest, so initial velocity is already going to be known as a zero. So that's 0 meters per second plus acceleration, which is going to be 9.81 because acceleration is identified as gravity, and gravity is 9.81. So 0 meters per second plus 9.81 meters per second squared times sine theta, because sine is opposite over hypotenuse, and that's what we're going to have to utilize to find the final velocity of the bowl going down the magnitude. Okay, so now we got initial velocity plus acceleration times sine theta 30 degrees times the time, which was 1.9 seconds. Okay, so let me go ahead and put this in my calculator, and I'm gonna let you know what I got. All right, so we got 0 plus 9.81, which is the acceleration, times sine theta, which is sine 30 degrees, times the time it took from to get to the initial spot to the final spot. Okay, now that we can conclude that the final velocity equals 9.3195 meters per second. There you have it, easy as can be. I hope so. We identified how to find the final velocity of the magnitude. We identified what axis of the graph to use, and we also identified like how to make something step by step and to simplify it. All right, you already know who it is. Check out my brand. I'm gonna post this on YouTube. No excuses win. This is my baby right here. If you like the content, hit a subscribe, give me a comment, whatever. I hope this helped you out, and I'm looking forward to getting an A on this. All right, peace.